Let's talk about how to solve some exponential and some logarithmic equations. So whenever we're solving an equation, we usually like to isolate the thing we're solving for. So, for example, if I'm wanting to solve for x, we like solving for x, in this equation, I want to get the x by itself. So that means I want to first isolate that e to the x. So I want to kind of peel away the layers, like peeling away the layers of an onion. If I'm wanting to get this x by itself, I want to get that e to the x by itself. So if I'm peeling away the layers, that means I want to get rid of that minus 5 first. All right, that's not too bad. I think I can just use my algebra and add 5 to both sides. So far, so good? So I have 2 times e to the x equals 6. All right, that x is still not isolated. Let's peel away some more layers. Sure, let's get rid of that too. I can divide both sides by 2. Again, algebra is my friend. Now that x still isn't isolated, I'm pretty close, but it's a part of this e to the x. So now algebra doesn't really help me anymore. I'm going to have to use my knowledge of how to undo an exponential. I want to get that x by itself. And I think, wait a minute, logarithms kind of undo exponentials, right? Since logarithms are the inverse of an exponential. So to get that x by itself, I can simply rewrite this as a logarithm. I can rewrite that in logarithmic form. So we remember how this works. The e is the base of the log base e of my number, which is 3, equals my x, right? E to the x equals 3. But wait, log base e, that has its own notation. Of course, that's the natural log. So rather than writing log base e, we usually just write natural log. And then that's something I can put in my calculator, right? And find the answer. So again, we solve an equation like we solve most equations. We want to isolate the thing we're solving for. So I first added 5, I divided 2, then when I'm left with my exponential piece already by itself, I can rewrite that as a log. And for those of you who need some reminding, remember if you have b to the x equals n, that's the same thing in logarithmic form as log base b of n equals x. Can I do that same kind of thing, solving logs? Well, sure. I still want to isolate the thing I'm solving for. I'm wanting to isolate that x. Well, that x is kind of spread out. So somehow I want to scoop those together if I can. And I think, hey, I have the log base 3 minus the log base 3. I can use one of those log properties. Subtracting logs is the same as dividing. Since logs are exponents, right? When you're dividing, that's the same as subtracting. Okay? So I'm trying to isolate my x by condensing this side. Sometimes we talk about using the log properties to condense each side. All right, my x's are a little more grouped. There's nothing else I can peel away except for that log. So again, algebra isn't going to help, but using my knowledge of the relationship between logarithms and exponents, I can undo this, right? I can undo or get rid of the log by rewriting this in exponential form, right? So I'm just rewriting that using my handy dandy little knowledge here. So b to the x, so 3 squared equals x plus 1 over x minus 1. And now I don't have the logarithm. Now I just have some algebra to do. All right, well, I think that 3 squared can become a 9. That's not too bad. X plus 1 over x minus 1. All right, I'm going to do my tried and true, multiply both sides by the denominator. Whenever I have a denominator, that's always a handy way to do it. Multiply both sides by the denominator. Okay, so I have 9 times x minus 1. I'm going to remember to distribute that. 9x minus 9 equals x plus 1. A little more algebra. I'm going to subtract x. 8x minus 9 equals 1. Add 9. 8x equals 10. Divide by 8. 10/8, which is the same as 5/4. Now you always want to make sure that you're not in trouble. Sometimes with logarithmic equations you can end up with what we call extraneous solutions. So I'm just going to do a quick check here. If I were to put 5/4 in here, I want to make sure I'm not taking the log of a negative number, because as we've discussed before, that's impossible, right? I can't raise 3 to some power and end up with something negative. So 5/4, it's a little more than 1. A little more than 1 plus 1, I'm safe. Okay? Ooh, let's make sure here. 5/4 minus 1. Well, 5/4 is a little more than 1, so I'm pretty sure I'm safe. Of course, you could use your calculator to check this, and I think you'll find that it works.